All right, so 8.2, we're going to learn about arithmetic sequences and partial sums. So again, continuing from 8.1, now we just have like a little bit more organization going on. It's going to give us a few numbers. We're going to come up with the equation for it, and we have a formula for that. So a sequence whose consecutive terms have a common difference is called an arithmetic sequence. So if we go from one number to the next, and add the same number every time, that common difference is what makes it an arithmetic sequence. That common difference. So we're just going to be adding the same number each time. And that common difference is D. So when we get into the formula, that is what D stands for, common difference. So example 1, it gives us a sequence whose nth term is 4n plus 3. So this is our a sub n equation. We can plug in whatever number we want for n and find that term in our sequence. Remember, n is the term, the number of term. The number that we multiply to n is 4 is our D. That's our common difference. And then the number we add or subtract is our a sub 0. So our 0th term. So if it gives us the equation here, we can plug in 1, we can plug in 2, we can plug in 3, we can plug in 4, and find each term in our sequence. So we see here, we add 4, add 4, add 4. 7 is our first term, 11 is our second term, 15 is our third, 19 is our fourth. How would we find our 0 term? Subtract 4. So to go backwards, we would subtract 4. So our 0th term is 3, which, if we look at our equation, that's where that 3 comes from. So for all of example 1, I think there's A, B, and C. It's not like asking us questions, it's just kind of pretty much gives us the answers and we just explain what's going on here. So again, this is our formula, same thing in the one before. This is our a sub n. The number that's getting multiplied to n is our d. So this one's just written in a different order, but still that number that's being multiplied to n is our common difference. If it's negative, what do you think we're doing to each number, each term? For a common, we're subtracting 5. So each time we go to our next term, we subtract 5. Subtract 5, subtract 5, subtract 5. That's our common difference. The 2 is our first term. How do we find the 0 term? Add 5. So again, we're going in the opposite direction. So instead of subtracting 5, we would add 5. So our 0 term would be 7, which is again where this 7 comes from. C is the same thing. We're going to skip it. So next page. Here's another formula. Same thing we just did. This says a sub n is equal to a1 plus n minus 1 times d. So the way we were doing it on the last page is we said a sub n is equal to d times n plus a sub 0. Again, these two formulas will give you the same thing. No matter which way you do it, you will end up with the same answer. 13. So let's go to example 2. We have to find the formula for the nth term of the arithmetic sequence whose common difference is 3 and whose first term is 2. So if we plug it into the formula, a sub n is equal to a1 plus n minus 1 times d. What is our d here? 3. Tells us our common difference is 3. And then, what's our a sub 1? 2. So we just need to plug those in. So we have a sub n is equal to 2 plus n minus 1 times 3. How would we simplify this? Oh, d is 3. Oh, I plugged that in. How would we simplify? What should we do? We want to distribute the 3 to both things on the inside. So we have a sub n is equal to 2 plus 3n minus 3. What else can we do?
2 minus 3.
2 minus 3, which is?
Negative 1.
Negative 1. So a sub n is equal to 3n minus 1. And that's our equation. That's our formula. All right, our next example. Example 3. The fourth term of an arithmetic sequence is 20 and the 13th term is 65. Write the first several terms of this sequence. So our fourth term is 20. So a sub n is equal to 20. A sub 4, because we know it's our fourth term. So a sub 4 is equal to 20, and a sub 13 is equal to 65. This is what we were given. We need to first find how many terms it takes us to get from the fourth term to the 13th. How many spaces do we have from 4 to 13? Nine. There's 9 numbers in between. Well, 9 spaces, I guess. Now, when we plug this into our formula, it's a little bit different here, just because it gives us 2 numbers that are part of the sequence. Neither one is our a sub 0 or a sub n. And we don't know what our d is, so we need to figure it out. So we always start with our larger term, so that would be 65. So we have a sub 13 is first, is equal to a sub 4 plus however many spaces we had in between, so 9 times d. So you always want to start with the larger number. We put a plus because if we see from A4 to A13, our numbers are getting bigger, so we're adding our common difference. And then 9 is the spaces. Now let's plug in what we know. So what's a sub 13? 65. What's a sub 4? 20. And then plus 9 times d. Now we want to solve for d, so what should we do?
Subtract 20 to both sides.
Subtract 20. So we get 45 is equal to 9d. What do we do next?
Divide by 9.
Divide by 9. So what's our common difference?
5.
5. So now we can work backwards to find out what our 0 term is. So here, we'll do it on this side. our fourth term, term 4, if my iPad works. There we go. Our fourth term, we said was 20. What would our third term be? If our common difference is 5, that means we add 5 each time here, but we're going backwards, remember. So what would our third term be? 15, because we subtract since we're going backwards. What's our second term? 10. What is our first term? 5. And what is our zero term? 0. So for our formula, if we have a sub n is equal to d times n, so what's our d? 5 times n plus our zero term. So what's our zero term? 0. So our formula is a sub n is equal to 5n. And we can always check our work once we come up with our formula by plugging in. We can plug in 4 here, and we would get a sub 4 is equal to 20. We could plug in 13 there, and we would get a sub 13 is equal to 65. So you can always check your work by plugging in the two numbers that it gives you at the start to see if your formula is correct. So when it gives you two values, you want to plug them in to this.
Wait, can you scroll down a little bit?
Oh, yes. All right, you guys good?
Yeah, thank you.
The next one, it tells us to find the 54th term in the arithmetic sequence. So first thing we want to do is find our common difference. What do we have to add to go from 2 to 9? We add 7. What about from 9 to 16? We add 7. And from 16 to 23? We add 7. So 2 is our first term. 9 is our second term, 16 is our third, 23 is our fourth. And what is our D? What's our common difference? 7. So in our formula, we have a sub n is equal to d times n minus a sub 0 plus a sub 0. Just depends on if it's positive or negative. So a sub n is equal to 7n. And then we need to find what our a sub 0 is. So if we're going backwards to find what our 0 term is, what do we have to do? Subtract 7. So it's 2 minus 7. Negative 5. So we would have 7n minus 5. And that's our answer. Oh wait, this one asks us for the 54th term. So we have to plug in 54. So we have a sub 54 is equal to 7 times 54 minus 5. What's 7 times 54? 378 minus 5. 373. So that's our 54th term. Now once we find our common difference, we could just keep adding 7 to the next term, to the 6th term, to the 7th term, to the 8th term, just keep going and going and going. That would be a whole lot of work. And it's easy to make mistakes that way too. So it would just be a lot easier to find the formula and then just plug in 54. Because you're not going to have time on the quiz or test to just add 7 54 times. Alright, next one, is that next page. Alright, so next we are finding the sum of a finite arithmetic sequence. So finite means that we have an ending. We're going to have a first term and a last term. It gives us this equation here to find our sum. What is n? What does n stand for?
Term.
The number of term. A sub 1 is going to be our first term, and a sub n is going to be our last term. So we need to know how many terms we have, our first term and our last term. And we just plug it into this formula, and we can find the sum of all of them. So let's look at example 5. So for this one, we could just add in our calculator, 1 plus 3 plus 5 plus 7 plus 9 plus 11. But if it asked you for the sum of a sequence with 100 terms, that would be a lot more work. So what we can do is plug it into our formula. So how many terms do we have here?
10.
10. So just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So we're looking for the sum of our 10 terms. And that is equal to, our number of terms is 10 over 2. What's our first term?
1.
1. And what's our last term?
19.
19. So what is 1 plus 19?
20.
20. And what's 10 divided by 2?
5.
5. So what is 5 times 20?
100.
100. So the sum of all 10 of these terms is 100. Alright, last question. We need to find the 150th partial sum of the arithmetic sequence. So it gives us 1, 2, 3, 4, 5. 5 terms. But it tells us that we have 150 terms here. So first thing we need to do is find what our 150th term is. Because we need our first term, our last term, and the number of terms to plug it into our formula. How can we find our 150th term?
Find how many is being added to each.
First thing we need to do is find our common difference. So how many are we adding to go from 5 to 16?
11.
And what about from 16 to 27? 11, and then 11, and 11. So what's our common difference? 11. And then we need to find what our a sub 0 is. So if this is our first term, what would our 0 term be?
-6.
-6. So we subtract 11 to go backwards. So this would be a -6. Oops, this should be an N, not a Z. So this is our formula. What do we need to plug in to find the 150th term?
Uh, 150.
150. So a sub 150 is equal to 11 times 150 minus 6. What is 11 times 150?
1650.
1650, and then minus 6.
1644.
1644. So this is our 150th term. Now we plug it into our partial sum formula, so that would be S sub 150, because we said we have 150 terms in our sequence. That's equal to our number of terms, which is 150 over 2, and then our first term plus our last term. So what's our first term? 5. And our last term, we said, is 1,644. So we have 150 divided by 2, which is 75. And 5 plus 1644 would be 1649. So 75 times 1649 gives us what?
So just 75.
Awesome. 123,675. Perfect. And that's our sum of the 150 terms in our sequence here.